Hello everyone, this is Free Name on YouTube here. This could be one of my least interesting videos depending on the outcome. I've always been interested, inspired by Andrews and Arnold, who had a can you run ADSL or maybe VDSL over a wet piece of string. I would like to know whether you can run fibre broadband through a glass of water. So in my test setup here I have a fibre router with a fibre module in the back here and different connector, so I've had to use a converter to go from SC to LC, and then we've got a small fibre patch lead going into, over here, a media converter with a module in it. So if I unplug the fibre lead over here at the media converter, one of the lights should go out on the media converter, and the internet light over here on the router also goes out. And on the laptop, which is pinging the internet, we lose access to the internet. So if I plug this back in, we should receive internet again. Here we are, your finest tap water from England, and there's our fibre lead. So time to chop it. What we should see here, a bit like when I unplugged it, is the moment I cut it, internet should go off. Over on the laptop we've lost pings, as we would expect. So if I take this end and put it in the glass of water, take this end, put it in the glass of water, do we get a link? And I've now answered my question, and as I thought, it was going to probably be quite a boring video, but no, we do not get a link. So the next thing is, if I move these cut ends very close to each other, does anything happen? And then the next thing is, if I strip the ends and then maybe even cleave the ends, does anything work? Right next to each other, in the water, no, they don't work. Next thing that some people do try is, can you tape the cut ends together? So I'm just going to hold these together. No. So if you get a bit of sellotape, even if you do it probably as accurately as you can do, just holding or trying to place the fibres together is very unlikely to achieve any kind of stable or working internet. So move on, and so this is all stuff that you could have done without any specialist fibre tools. All you needed there was some scissors, assuming that you have access to a splicing kit and some fibre strippers. So let's move on to if we had the ability to do more work to the fibres once they've been cut. So what I'm going to do here is take off the outer coating and move away the Kevlar. Probably chop that Kevlar off as well. Just so that it's out of the way. There we go. And let's strip a bit off the end of the fibre. This lead is not made to be spliced, so it's going to be quite difficult getting the coating off of here. Alright, that wasn't too bad there. So that's one end is stripped. Do the next end. And the other end, okay, that actually went not too badly. So now there's a lot more surface area that isn't covered where light can escape. Let's dip both of those back into the water and see whether we obtain any kind of connection. And if I move the ends close to each other, no. So even there. Trying not to cover things with my hands on the camera. Even crossing the beams, in the glass of water doesn't result in a working internet connection. So there's not enough, I guess, spillage out of the side of the fibres to make it work within that glass. Now we've stripped these fibres, is there any chance that we can get some working internet by trying to line these up? Or holding them next to each other, I guess may be a good one. Do you get any kind of crosstalk just holding the fibres next to each other? The answer to that is definitely no. Next thing, cleaving the fibre. So at the moment the end will be jagged and a total mess, which in fact I can probably show you and will be interesting. So here we have the fibre splicing machine, or splicer. If I put one end of this in the splicer, what you'll see on the screen of the splicer are two camera views of the same fibre, and you'll see that the end of it is a total absolute mess, which probably for this test of whether it will work through a glass of water is a good thing, because it will be spraying the light in all sorts of directions and making it more likely to be picked up by the other end of a very jagged interface. But, so that is a total mess here. If I take the other lead, we'll see what kind of situation the other end of the lead looks like. Which will probably be an equivalent mess. Yep, it is indeed. So remember what that looks like. What I'll do now is prepare and cleave the fibres. So need to scrape the coating off of both sides. And I'm not doing this out in the field for any kind of production use, so I'm not going to do an alcohol rub cleaning of the fibre. It's just totally irrelevant for this test. So those now have the acrylic coating scraped off the edge of them. And for when you do a splice, you need two flat interfaces to get a good join or a good optical path through the join. So you have a cleaver, which I think will, I'm afraid, just be off the camera, but what that does is runs a blade, which is there, across the end of the middle of the fibre, creating a new totally flat end. So let's do the one that was, well no, it doesn't really matter which one you do, let's do that. So that's now cut. If I now put it into the splicer and we close the lid, you should see, instead of it being a total mess, it is a very obvious flat end on which we can do a join. So now I've got two flat ends. I will retry the water experiment to see whether having a flat end into the water makes any difference to whether it's likely to work. So we're back with the glass of water. Let's see if I can get the brightness correctly there. Dip that one in. And dip that one in. So no, you cannot use a glass of water to connect your fibres. So the next thing, which might be an interesting test, is just how communicative through water different frequencies of light are. So this frequency of light in one direction is 1310 nanometers and in the other direction is 1550 nanometers. If I get something which is much lower in the visible light range, which is 650 nanometers, and we chuck it into this glass of water, it'll be interesting to see how much light becomes shed or visible. Before I do more, let's move the very expensive bit of equipment out of the way. So this is a visual fault locator, which is basically like a laser pen, and it has a flashing mode there and a solid on mode. So this is it without anything plugged into the end of it. If I now take the fibre and plug it into the end, you should see at the end of the fibre it's now taking the light is coming out of the end of the fibre. If I take this fibre here and I bend it, you can also just about see that where I do a bend, light escapes from the fibre. Then if I make it straight again, let's do it over here where it's more obvious, bend, and then if I make that straight, the light no longer escapes from the fibre except for at the end where we want it to come out. So now, okay, putting that into a glass of water looks like it doesn't really spread much, other than if I point it at the edge of the glass where it then just reflects off of the glass. My thought of the water will make it essentially make the light go everywhere is definitely not what happens. So now makes kind of sense to me why even if you put two ends of the fibre into a glass of water, not enough light gets back into the correct place on the other end of the fibre to make it to reach the other device. There we go. You cannot join fibres using a glass of water, unlike VDSL or ADSL, which you can run over a wet piece of string. Hopefully this video has been interesting to you. If it has, it would be really helpful to me if you wouldn't mind subscribing to my YouTube channel. You don't need to have the video notifications switched on, but the subscriber numbers really do help. Thank you very much. So the next challenge is, if you've cut some fibre by mistake and you would like it to be working without having to call out your ISP, what can you, as a normal user, do to get it working again? And the best I can think of is finding something with a very sharp V groove in it, a very small, very sharp V groove. So I'm folding up a bit of paper here, probably multiple times, so that it's not taking up all of the space where I'm filming, and making it an incredibly sharp edge where it's creased together. So let's see whether if I rest one bit of the fibre in there using the tension of the fibre to hold it into the groove, and if I then get the other bit of fibre and again using the tension of the fibre to hold it into the V groove, can we obtain some sort of connection? So I can tell that they are, I believe, touching, because when I try to slide them together they stop moving. Yeah, they're definitely touching there, but absolutely even that kind of alignment is not enough to make them work. And bearing in mind these have been cleaved as well, so they've got a really good optical interface at the end of the fibres. So that's quite astonishing to me. I would have thought that having this kind of proximity and not necessarily fully accurate would be enough for a service to work, but I can tell you that definitely does not work. Well, there you go. Bringing back the splicer, let's see whether we can just get this service working again as a demonstration that these fibres do actually still work. The join is probably not going to even succeed or go ahead because of the damage just then while butting the fibres up against each other, but it will probably be lined up enough within the splicer to work while it's in the splicer. Let's close the lid and see whether the internet starts working once it's lined up the fibres. So yeah, they've definitely got damage since testing. Oh, I actually will do a join. And the internet's already working. So the fibre, the splicer doesn't like it. It's seen an optical issue because I've been just smashing the fibres together in that bit of paper. But while it's in the splicer and lined up accurately, we do have internet back. So this fibre that I've been messing about with definitely does still work, and over here we've got ping to the internet. But you can't do fibre through a glass of water, nor can you hold it together using a bit of paper or your hands or a bit of sellotape. that was fun. Hopefully you found the video fun as well. Once again, it would be really helpful to me if you wouldn't mind subscribing to my YouTube channel. Thanks.